Welcome to the Private Wireless podcast series from Nokia, bringing you the insights that really matter around enterprise digital transformation and wireless solutions. The series covers technology comparisons, deployment best practices, total cost of ownership assessments, analyst reviews and reports to help you make the decisions you need for your business. So keep listening. Today, we'll hear from James Blackman of Enterprise IoT Insights as he chats to Stefan Doble, Head of Marketing at Nokia Enterprise Solutions. They discuss the key considerations for enterprises looking to enable digital transformation with private cellular.
So, Stefan, if we go through this decision-making process quite kind of systematically, let's start with the type of network coverage that is needed to connect critical OT in the industrial space, and whether it is essentially, geared to connect people and processes and machines in defined locales, or whether it is for wider area mobility and broader regional or kind of national coverage. Just if you can, Stefan, talk to me through that kind of first consideration.
Yeah, thanks, James. That's indeed very important that we talk about the fact that the enterprise have a need for, what we call critical OT connectivity, both within their location, but there are also quite a few segments that need this kind of wireless critical connectivity, in the wide area as well. When, some of their trucks, for example, are driving around, or when you've got some fixed asset out in the field that you need to connect as well. So there are segments, for example, airports, ports, or even mining, where most of the needs are around the industrial site itself. While you've got other companies like take logistics company, for example, that need connectivity in their warehouses, for example, and distribution centers, but also on a nationwide level. So you have effectively the industrial site need, and then you've got the wide area network connectivity need. And then, when you look at the wide area network connectivity need, we also need to differentiate certain segments. Take utility, for example, or the rail industry, where they have what's often called field area network, where effectively they need connectivity out in the field, but realistically only limited to the place where they have assets. So, for the utilities, for example, the power utility, that would be connectivity that follows their grid, effectively, the power lines. And for the case of the rail, that would be connectivity that's just following their tracks. And in that sense, those can be considered as site, but realistically they are, in the wide area network. So that's why they often call field area network. So these are the kind of different, really the three different kind of environments we need to look at. And generically, private wireless networks are the most suited solution when it comes to industrial sites. But while, when you take a look at the need for wide area coverage outside, using a slice of a mobile operated public network may actually be more suited and more economical when it comes to wide area network connectivity, like, the case of a logistician that wants, tracking of the delivery trucks, for example. But at the same time, going back to field area networks, we have, seen quite a few cases in the past of what we call will be really large private wireless deployments that, for example, tackles this field area network needs, so connectivity that goes along the track of rail networks, for example. But anyway, in a net, when you look at the wide area network connectivity, there's quite a few factors that comes into play, like the level of criticality. For example, a smart city may find better to use a public network for the parking meter communication because they're a bit less critical, whereas a power utility may favor a private wireless network to monitor their grid, as it's a bit more critical and can even lead to fire, like we've seen in California, 2 years ago.
Right. Okay. So there is this consideration up front about local area versus wide area coverage, and about kind of field area networking somewhere in between. Let's zoom in, Stefan, if we can, on these local area cases, just because, that is the heartland for private cellular. Explain again for me why private wireless is the best choice for connecting critical processes and things in these industrial sites? And why not go with a slice of the public 5G network, say?
Yes, definitely. So, well, when you take a look at private wireless and why we feel, and the experience has shown that is better suited for industrial sites connectivity, is there's a couple of key reasons. But I would say the first one is when you talk to enterprise, they have been for the last 20, 50 years used to effectively own their local area networks. That's almost part of their some of the key assets. And they like to be in control of the networks, or at least be the owner of the equipment that runs those local area networks for the sake of privacy and security. Even if it's true that in quite a few cases some companies outsource the management operation of it, but a bit less when it comes to effectively the local area networks that runs the OT side, the machine side. That's typically more kept a little bit in-house. And it's the same with private wireless. When we talk about private wireless, we talk about OT for business and mission critical application that have even more stringent requirements. And there is a general tendency to want to effectively own and operate those networks. So that's probably the first reason. Secondly, which is kind of a bit more around performance, and while 5G will introduce slicing, enabling to provide a certain control over the performance over a public network. And that would be great for those kind of wide area network critical connectivity we're speaking about, or some of the field area network connectivity. With most industrial sites often being in non-urban area, meaning in not very good coverage area, and you are still in any cases limited by the laws of physics. So you cannot really beat a local deployments that has been designed and has devoted solely to connect key elements, whether it's users or system, inside an enterprise location, where you may want to have dedicated and deep coverage, for example, indoor. When you've got a big wall or a metal shell around a factory, your indoor penetration from outdoor cell will be limited. So you'll want a deep indoor deployment that provides them dedicated connectivity, like in an underground mine, for example. And then generically, latency and capacity are really key for critical connectivity. And again, you cannot beat having a private wireless network that's solely dedicated to the elements you think are essential to run on it. Because even those networks, when they are deployed in industrial site, will not be used to connect anybody's laptop. It will be dedicated just for the machines, for the critical sensors and critical workers. So that's probably the second point. And then thirdly, I would say around reliability and predictability are really key driver when it comes to OT critical applications. And while a sliced public network is actually able to provide a good performance, and that's going to be very essential when it comes to wide area network connectivity, some of the testing that we have done shows that even with dedicated small cell inside an industrial site, but connected back to a public networks, tend to increase the latency, just simply because there is a longer distance between the cell and the core elements. So the cell deployed on site and the core elements deployed in the operator's locations. And generically, you have also inherently a lowering of reliability just based on the fact you are dependent on a public transport network. So if somebody is somewhere, digging a road, it may break up the fiber lines, for example. So you may just lose connectivity because of that. So that's why, probably the key three reasons why the enterprise tend to favor private wireless for industrial site versus leveraging public networks.
Okay, so that seems clear. We feel like we know and understand the case for private wireless to be deployed in these industrial sites. And I'd suggest the interest from the industrial sector, in the last 12 months and very much so in the last 6 months reflects the kind of logic there. But then the next question is, once you've decided to go private, who do you rope in to supply it? Because there are a whole bunch of players out there. It's not just the traditional telco community anymore. So, Stefan, who are all these suppliers? Just talk us through, if you can, what the options are for enterprises in terms of the supply of these private LTE and 5G systems.
Yeah, thanks, James. Good question. And indeed, like any growing market, with a lot of potential. We've got to remember here that we are talking about potentially having to deploy private wireless networks in over 13 to 14 million industrial sites at minimum. So there are indeed a lot of players in that space, and a lot of new players coming, to serve that market. And the first one that probably started the trend actually came from the telecom vendors such as Nokia, and Nokia was one of the first to deploy private wireless networks in Australia back in 2015 for Rio Tinto in an open pit mine. So that this is clearly one of the area where telecom vendors have felt there was an opportunity in that space. But at the same time, as we go along, already today Nokia has over 50% of our private wireless customers come from indirect channel. As many enterprises have very clear preference on who to work with when it comes to choose partner for OT critical connectivity and including private wireless. And so this is very likely to grow over time as private wireless become more mass market, and we try to address also the SME space. So clearly the telecom vendor are one options. The second obvious player in that space, as Fury you would have imagined, are the mobile operator or the communication service provider that indeed have a lot to offer in that space. They have spectrum, which is an important part of the puzzle. They also have the expertise in running and managing such 4G and 5G networks for our mobile subscription that we use every day. They've already got good existing and relationship with the enterprise space. So they have clearly the sales channels to this market, but they also have this ability to offer that critical connectivity nationwide that we talked about for wide area networks. So in some specific segment, that makes them really the prime the prime player. Because they can offer both the sites connectivity as well as the wide area network connectivity. And then finally, you have quite a few of them that have a dedicated business arm, like, for example, Verizon, AT&T, or Orange, who Nokia work with, who already provide, enterprise IT and system integration and LAN services to those enterprise. So for them, it's just an additional offering that they can offer to the end customers. So that's the CSP side, and we expect them to be a big player in that space, with more and more operators developing an offer around private wireless. Then you also have, the other range of, let's say, communication service provider that more coming from the IT or the cloud space, who are also looking at the opportunity to provide private wireless. Companies like Microsoft, who Nokia has a partnership with, effectively deploy a lot of edge cloud servers within enterprise to run some of the Azure IoT range of solutions. And they also offer, as part of the edge cloud catalog, an application to run, for example, Nokia Digital Automation Cloud solution as well. So they can also offer private wireless, and they're starting to do so more and more. Then, some of the survey that we've done and the experience we have from a lot of industrial enterprise also show they have a big trust in ecosystem players, but also system integrator, where they tend to favor effectively buying complete end-to-end solution that also integrate the element of network connectivity into it. So, for example, there are some very key applications that are enabled by private wireless, where effectively private wireless is a key component of the total offering. So if you take, for example, the mining space as an example, or even in the ports industry, autonomous haulage, autonomous trucks, autonomous straddle carrier, for example, are one of those key applications that helps boost the efficiency of those industry. And we sometimes deploy private wireless via the system integrator that is effectively taking care of enabling autonomous truck in that mine or in that port as well. So these are another channel to market. And for example, in manufacturing space, that's also a place where they trust a lot the system integrator for the critical network connectivity of the machine. So that could be another channel to network connectivity. To that, a bit more recently, we've also seen a lot of IT players or IT system integrator that also wants to be involved in that market. Take a couple of examples, Accenture or DXC, who are also Nokia partner, are offering Nokia private wireless solutions to their customer. And then finally, we have plenty of other, maybe distributors, SIs, and consulting firms that are all, interested in the private wireless, because it's a key enabler for the industry 4.0, and it's again something that they have, for the consulting firm, something they can bring value when they are consulting with companies. So we are working, for example, like with company like Ernst & Young, for example, in the manufacturing space.
Okay, very good. So we know there are lots of choices in terms of suppliers and things to recommend each of them. But what else do we need to think about here? Because there are other things to consider behind all of this, there is, of course, this question of access to spectrum as well. Just, Stefan, if you can talk about that a little bit and how that market's changed.
Yeah, definitely. And there is indeed a link between who you get your private wireless networks from and the spectrum also. So, the choice of partner, you also need to consider, the spectrum aspect. As we talked about, the CSP, obviously one of the key players to come with spectrum, let's put it that way. But so looking back at spectrum, so in some market, there are more and more countries that are now releasing spectrum that vertical can access and use. And you can take as example France, that was really one of the first one to release spectrum for vertical, the UK, Germany, or even US with CBRS. So in those markets, and there's quite a few more that I mentioned, you have basically all the choice possible. You can go and work in any of those partners we talked about before, and even actually CSP are also building their offer, like you've seen with the AT&T announcement, really with the use of CBRS. So even the operator can use those vertical spectrum to serve private wireless market. So in those markets, you can basically work with almost anybody. But in the market that have not yet released vertical spectrum, or where the vertical spectrum may not be fitting, you're probably going to have to work with a partner that can bring spectrum. And obviously the obvious ones, as we talked about, are the mobile operator. Nokia has also, as part of his private wireless offering, has quite a bit of sponsorship with many spectrum owner. So effectively, we're able to bring spectrum and the solution. But the alternative in those markets is either you work with companies that have spectrum, or you need to look at using private wireless that works in unlicensed spectrum. For example, the Wi-Fi 5 GHz spectrum using a technology called multi-fire that allows the operation of LTE 4.9G in the Wi-Fi spectrum. Meaning you can just deploy it without asking anybody, without even signing a form for, like with the vertical spectrum use. And while, there'll be a few, limitation on multi-fire, you still get most of the benefit of LTE and 4.9G when it comes to security, mobility, capacity, predictable latency, using the technology. That could be a good approach as well.
Okay, so it feels like we're better positioned, to make a decision about where to deploy this stuff and with whom. But once those things are out of the way, once the type of coverage, the availability of spectrum, the choice of partners have been dealt with, what are we left with? Because there is a technical decision to make as well, right, about the solution itself. Just talk us through the main options there.
Yeah, you're right, James. I mean, once you've covered spectrum and where you can get private wireless from, like any other networking technologies, there's different ways to create a private wireless network. And while it's always challenging to cover kind of architectural kind of discussion on a discussion like this, let's maybe try to cover the key principle and approaches, knowing there's obviously a lot of different possible approach. So the first part, let's tackle that piece because that's probably the easiest, is the radio aspect. So effectively, to create the dedicated coverage in the industrial sites, you often have indoor and outdoor spaces that you want to cover, and even rugged areas or more challenging hazardous area in the indoor space as well. So in any case, private wireless use what we call small cell BTS, or sometimes called access point. And these small cell, they're not very dissimilar to what everybody's familiar with in terms of Wi-Fi access point. When it comes to the size and the shape of it, they are typical gray boxes, ranging from 2 liters to 10 liters, let's say. But they are quite a bit more sophisticated than Wi-Fi when it comes to both capacity, capability, performance, but also much higher coverage. And typically you'll need, even in the indoor space, about 1/10 the number of LTE small cells to get similar coverage than Wi-Fi, which means you need 10 times less. In outdoor space, this is where, again, the benefit of LTE 4.9G and licensed spectrum means you can have small cells that provide higher output power and gives you the ability of covering, several kilometers worth of coverage, and even more in the tens or 20 kilometers for, even bigger small cell that we call often mini macro BTS. And that means that you can, for instance, cover very large surface mining operation, ports, harbors, or even offshore wind farms with only a couple of outdoor small cell. So that's the baseline. So your private wireless network start with a radio, with radio deployed strategically to provide the good and deep coverage that you need for your operation, even connecting, sensors inside machines and trucks. And that's done with radios. Then the second part is it comes down more to the architecture, and that's where also there is a big difference between Wi-Fi and LTE. A private wireless networks effectively to function and be coordinated and provide this performance and mobility and everything else needs what's called a core network. And this is where there are different ways of providing the functions and feature of a core networks, and the radio will be backhauling the data to. So to make it simple, there's really a choice of three main architecture with a lot of variance in between, but let's try to keep it simple and down to three. So the first one is what we typically, or the industry would call autonomous private wireless network, which effectively you have all the functions, including the core, the management, and the application deployed locally at the industrial site itself. It could also be deployed at a headquarters with edge cloud deployed in each site, but then it becomes a bit more complex. So let's assume everything is deployed locally. And this is what we've this is the traditional private wireless architecture, and it's the one that we've been deploying since 2015. Then, a bit more recently, Nokia was the first to introduce what we call private wireless as a service. And this is where you effectively have almost all the parts of the core networks and the application deployed locally on an edge cloud server. But then the management piece, the management elements effectively sits either in the cloud or in your own enterprise data center somewhere else, and effectively and enable you to have effectively the benefit of private wireless without necessarily the complexity. So that's one model which is becoming increasingly important. The final one is the one I would maybe describe as core slicing, where you only have the minimum of the core element and application that you need locally to ensure local enterprise data breakout. That means data doesn't come out of the enterprise, reliability and low latency, but the rest of the core element are effectively run by a service provider in its own servers and cloud, leveraging the existing component or the existing system. So effectively that could provide, let's say, the lower cost option.
So that's great. So Stefan, when does an enterprise then go all in with an autonomous kind of standalone option, and when do they go with a cloud-based as a service offer, and when do they ask for a piece of the action from the public operator? Can we rationalize this? What are the benefits and weaknesses, if you like, of each of these three main types of private wireless solution?
Yeah, this is one where it's, again, very difficult to give a definite answer, because there are really no good or bad option here. It will really come down to each individual enterprise based on what they want, their strategy, the number of sites they need to serve, how critical the connectivity they need is, how reliable they want the system to be, and how involved they want to be in operating a network. So it's a bit, of a challenge, and we really see, in the market a combination of those three main approach being very popular. But if we go back to the basic requirements of a private wireless network serving critical OT application, what those guys are looking for is reliability, good coverage, multi-user capacity, low latency, security, and basically all this really kind of provide that in a nutshell. But when it comes to, when it takes security and data privacy, which is a very important factor, in all options, this is preserved because the enterprise data stay local in all three of the options with what we call a local data breakout that functions on the site level and keeps the data within the LAN of the company. So that all of the solutions serve that need. Then the first two options fulfill, all the needs, and maybe I would say the third option, which is the core slicing, does provide a bit of a trade-off that could be acceptable for maybe the SME market that are not willing to invest that much for private wireless, or maybe when it's an enterprise where the application they're running are maybe a little bit less critical. The third option may be a good one. So really, if you look at it starting from autonomous all the way to core slicing, I would say, weighing the different architectural option in kind of is in the opposite of total cost of ownership. So probably, the initial capex and complexity is higher with an autonomous private wireless network, and as you move towards, core slicing through private wireless, you effectively lower that a little bit and lower also the total cost of ownership.
So, is there a linkage, Stefan, between the choice of the solution and the choice of channel? I mean, presumably there is some, and some channels only offer certain options. and others only want to offer certain options. Just talk around that a little bit.
So yes, you're right. So clearly, when you take a look at telecom vendors such as Nokia, the focus is more on autonomous private wireless network and what we call private wireless as a service. These tend to be the solution that telecom vendors tend to favor. But then if you look at the CSP, for example, we actually recommend, and we see that quite a few CSP are really looking seriously at all three options, as they that provide really a solution that's fit for each of the sub-segment of the market. So in that sense, I would say probably the CSP are the one that will probably have, let's say, the wider offering when it comes to to private wireless networks. What's interesting as well, to think about it, depending on the choice of partner, they would indeed be more leaning towards a cloud-based solution versus a dedicated autonomous private wireless network that's deployed as standalone, depending on who they're coming from. For example, with Microsoft, the digital automation cloud solution, which is a cloud-based with edge server deployed locally, is the favored solution for Microsoft. What's also interesting is when you start thinking about those models and you bring back the topic of spectrum, what's interesting is if a CSP is going to offer all three options, they could also combine this different architecture model with a certain spectrum tiering. So for example, you could consider that the autonomous private wireless option would be, they say, the gold offering, and that would be leveraging their own spectrum for the highest tier solution. Private wireless as a service could be offered with both their own spectrum or vertical spectrum. And finally, the core slicing would just use, for example, multifier to provide a very attractive market proposition for the SME market. So there's also a combination there between, the choice of solution and spectrum that could be used to create a very interesting offering to the market to really tackle all the different, sub-segments of the enterprise space.
And I just wonder, is there a shift or a trend between these three architectures, where perhaps the plug and play as a service option has kind of exploded the market kind of latterly, but works at the same time perhaps as a proving ground for more traditional looking network infrastructure?
Yes, James, to a certain degree. I mean, and if we think about it and start again from the beginning, as we talked about before, it started all with autonomous private wireless networks, but over time we saw, particularly last year, more and more demand for private wireless as a service. Particularly for industrial sites, since it really meets all the requirements they need in terms of confidentiality, reliability, and all the benefit of private wireless, but remove even more of the complexity of private wireless networks. And it's particularly obvious as well that private wireless as a service offer a very good solution with a lower entry cost and easier access because it's just a simpler solution. So any kind of trials or initial validation deployment, private wireless is a very good way to effectively test it out and then continue on afterwards, as it's easy to then grow and scale later on. So I think private wireless as a service is probably going to grow in size and in demand when it comes to industrial site. Where probably autonomous will remain the favored option are probably for larger networks. So, as we talked about, when you have industrial, sites like, for utilities or for rail or even for public safety, that needs both a coverage within a site, within a power station and a substation or even a train station for the rail or shunting yards. But at the same time need connectivity while out and about for following the grid on the rail, then I would say the market will probably continue to favor autonomous private wireless because it's just more customizable, and can offer additional capability plus give you the full control of the network. So that's probably where I see the market going in that sense. But at the same time, it's also hard to give an answer in terms of where the market trends are going. Just because with more and more CSP and partner entering the space, we see them as being a very good fit, for example, the CSP for addressing the SME market. As we talked about, the core slicing option that we talked about, that third option, may be a very attractive proposition that will develop in volume for addressing, the small and medium-sized companies that also want the benefit of private wireless networks, but don't necessarily have maybe the skill set, the capability, and want something that's kind of managed by a third party. So that may also be an area that we'll see more and more of in the future.
Our thanks to James Blackman of Enterprise IoT Insights and Stefan Doble, Head of Marketing at Nokia Enterprise Solutions, for joining us today. Thanks for listening to the Private Wireless podcast series from Nokia. Don't forget to subscribe and be the first to hear new episodes. If you're looking for more insights around all things private 4.9G LTE and 5G, contact the Private Wireless team at Nokia. To find us online, just search for Nokia Private Wireless and click Talk to an Expert to get in touch.